Everyone. Dr. Chandaram Pawar, working as an associate professor in the Department of Chemistry at Murray Lakshman Reddy Institute of Technology and Management. Today we will be discussing about polymers, some basics about polymers and their applications, and how this polymers module or unit is helpful for the undergraduate, especially engineering BTech students. Okay, so basically here we can see in our college we have 5 modules for BTech system. So module 1 is water and its treatment, which we have already discussed, and second module is battery chemistry and corrosion, which is already done, and now third module, that is nothing but polymers. So basically poly means many, mers mean units or parts. So combination of these parts, part is nothing but monomer. So combination of units or combination of monomers leads to polymers. So simply here monomer is the building block of polymer. Okay. Now let us see in detail. So here there are some references for this engineering modules. Engineering chemistry by P.C. Jain, engineering chemistry by Rama Devi, engineering chemistry by Tirmalachari, engineering chemistry by Jayasri Ani Reddy, and engineering chemistry by Sika Agarwal. These are some of the references. Now let us see. Matter is composed of many small units called molecules. Okay, that means molecule is nothing but combination of atoms. Atom leads to molecules, and these molecules leads to polymers. Okay, now the word polymer was derived from the Greek word, that is nothing but poly means many, mers means parts or units, which I have highlighted. Here we can see before this, after 10th standard or SSC, there will be a course called Polytechnic. Poly means many and techniques. Polytechnic, many techniques students will be learning. Okay, that's why Polytechnic program is there after 10th standard. Okay, similarly here polymers are nothing but many units or parts combined together for the formation of polymer. Okay, so polymer is nothing but combination of monomers. So combining monomers through covalent or hydrogen bonding leads to polymerization. Okay, now here we can see the number of same or different monomers combined together through covalent bond to form a big molecule or macromolecule or large molecule. Weight molecule is called polymer. Giant molecule, giant means what? Large. Large means huge. Macromolecule, monomer to large molecule. Monomer is somewhere micromolecule. Micromolecule to macromolecule. Smaller to large, that is nothing but polymer. Okay, now the repeating unit present in polymer is called monomer. So now what is the building block of polymer? Monomer. Okay, building block of polymer is monomer. Here we can see. So polymers are formed with the help of monomer. Monomer is nothing but unit or part. Now let us try to understand in general, broadly, what is the building block of body, human body? Cell. Cell is the repeating unit for the human body. That is nothing but Jeevakanam in Telugu. So cell is the building block of our human body. Similarly, Amino acids are building blocks of proteins. And when we talk about crystalline material, unit cell, smallest repeating unit is nothing but unit cell. And this unit cell is the building block of a crystal. So, human body is made up of cells. That means cell is the building block of human body. Similarly, amino acids are building block of proteins. Unit cell is the building block of crystal. So, similarly here monomer is the building block of polymer. Okay. Now, monomer gives rise to polymer. Okay. How it is forming? It could be AP. AP is nothing but addition polymerization. Or it could be CP. CP is nothing but condensation polymerization. Or copolymerization. Copolymerization. So, monomer to polymer formation takes place in three ways. One is addition polymerization AP, another one is CP condensation polymerization, third one is copolymerization. These are the three mechanisms which helps us for the synthesis of polymer from monomer to polymer. Okay. Now, when we talk about addition polymerization, again cationic polymerization, anionic polymerization, addition polymerization, 1 cationic, 2 anionic, 3 free radical. Okay. Addition polymerization categorized into three types: cationic polymerization, anionic polymerization, free radical polymerization, and condensation polymerization. Okay. Condensation polymerization is nothing but functional groups. It could be amine, it could be water hydroxyl group, it could be acid group, it could be aldehyde group. So, two different monomers with two different functional groups leads to covalent bond formation followed by the release of any byproduct. Release of any byproduct. It could be water molecule, it could be ammonia gas, it could be H2S, anything. Leads to the condensation polymerization. Now, to understand simply addition polymerization and condensation polymerization, in addition polymerization, something like double bond, unsaturated compounds or triple bonds, acetylene kind of molecules involved in the conjugation, and there is no byproduct, in addition polymerization. Whereas in the condensation polymerization, there will be definitely a byproduct. It could be water molecule, it could be ammonia gas, it could be hydrogen sulfide, whatever it may be. But definitely there will be a byproduct. Why? Because functional groups are like acid or water molecule or hydroxyl or amine groups together combine by releasing the byproduct. Best example is nylon 6,6 for the condensation polymerization. For addition polymerization, best example is PVC, polyvinyl chloride formation. Okay. Before going into discussion about addition polymerization, condensation polymerization mechanism, as we were discussing, vinyl chloride is the monomer for PVC, polyvinyl chloride. PVC is nothing but polyvinyl chloride. Okay. See, PVC is nothing but in our day-to-day life, whatever the pipelines we use for agriculture, pumping water here and there in the fields, or plumbers which works mostly for sending the water to the syntax which is there on the roof of our building. So all these Astral, Sudhakar, Nandyala, Nandi pipes, all these PVC pipes. Okay. Now ethylene is the monomer for polyethylene. PE is nothing but polyethylene, and this is nothing but plastic covers. Plastic covers are carry bags. Carry bags. So what is the polymer or monomer required for these carry bags, plastic covers? Ethylene monomer is required, and upon addition polymerization, this ethylene gives us polythene cover we call. If we go to market or any supermarket or vegetable market, so those vendors will be having these polythene covers to carry the vegetables or any other groceries. So what is this polythene cover? That is nothing but polyethylene. Polyethylene is formed by the help of ethylene monomer. Okay. Now glucose is the monomer for the starch. Styrene is the monomer for the polystyrene. Polystyrene clothes, garments, textile factory. Styrene is used as a monomer for the polystyrene garments. Garments is nothing but clothes or textile industry. So styrene is the monomer for the polystyrene clothes. Amino acids are the monomer for the proteins. Okay, as I said. Now here we can see one example to understand this polymerization. The process by which the simple molecule or micromolecule or monomer combined together through a covalent bond leads to the polymerization. Okay, combining of polymers, polymer A plus B gives rise to C. This is happening through covalent bond formation. Covalent bond formation. Okay. All right. Now let us see one example here. What is written? Ethylene. Ethylene comes from the ethane. What is ethane? CH3, CH3. This is ethane. Ethane. If you reduce two hydrogens, then CH2 double bond CH2. This is nothing but ethylene. Alkene. This is alkane. Alkane to alkene, ethene. Ethane to ethene. Okay. Now this ethene, which is alkene, undergoes polymerization. What kind of polymerization? CH2 double bond CH2. N represents number of monomers. Number of monomers involved in the polymerization. Okay. So from ethene to polythene. See, this is ethene or ethylene, monomer. This is monomer. Okay. From this ethylene monomer, we are getting PE. PE is nothing but polyethylene. Okay. Now This ethene to polyethene conversion happening through the AP. AP is nothing but addition polymerization. Addition polymerization. Okay. Ethene, alkene to ethylene, and here N represents how many monomers are involved in the polyethene formation. That is nothing but degree of polymerization. So N represents degree of polymerization. Okay, N represents degree of polymerization. Okay, that means number of monomers involved in the polymerization. Okay, now you can see here degree of polymerization dP is nothing but the molecular weight of polymer by molecular weight of monomer. How to calculate this N? N to calculate by molecular weight of polymer by molecular weight of monomer. For example, if you take molecular weight of polymer, that is Pe somewhere 500 by molecular weight of monomer somewhere 20. So whatever we are getting next is, that is N represents degree of polymerization. Okay. Now based on the degree of polymerization, polymers with a high dP is nothing but degree of polymerization, are called higher polymers. Their molecular weight range is in between 10,000 to 1 lakh Daltons. Okay. Polymer with low dP is nothing but degree of polymerization, that is nothing but oligopolymers. The molecular weight of these oligopolymers ranges from between 5,000 to 2 lakh Daltons. Okay. And based on occurrence, polymers are categorized into basically two types: natural polymers, which are raw material found in nature. A best example for natural polymers: natural rubber, protein, cellulose, starch. Okay. Not only these, wool which comes from the sheep, that is also a natural polymer. And then cotton which comes from the fields, agriculture fields. This cotton is also a natural polymer. Wool which comes from the sheep, animals, that is also a natural polymer. And cotton which comes from the agriculture fields, that's also a natural polymer. Okay. Apart from this, rubber, latex rubber, protein, cellulose, starch, these two are also comes under natural polymers. Now synthetic polymers. Synthetic is nothing but artificial. Artificial is nothing but man-made. What are the man-made polymers? PVC, polyethylene, polyvinyl chloride, PE, polyethylene, PS, polystyrene, Teflon, nylon. All these are the artificial. If we go to any sports stadium, badminton court or kabaddi court, there will be synthetic courts. That means man-made courts. Greenish mat will be there. That is a synthetic polymer. Synthetic is nothing but man-made polymer. And another best example is bakelite. Bakelite is nothing but the comb which we use for our hairing. Okay. Hair comb is nothing but bakelite, which is man-made, artificial polymer, not like wool and cotton, natural, or starch, cellulose. All right. Now, classification of polymers: homopolymers, heteropolymers. Homopolymers are nothing but same or identical monomers are involved here in the homopolymerization. Whereas in heteropolymers, two or more different monomers are involved in the polymerization. See here, what is written? Polymers are made up of identical monomers, means same monomers. Same monomers. Best example is PVC. What is the monomer here? CH2 double bond CH and this vinyl chloride. So vinyl chloride to polyvinyl chloride, PVC. So same monomer. Similarly, ethene to polyethylene. What is the monomer here? CH2 double bond CH2. Then CH2 double single bond CH2. This is PE, polyethylene. This is ethylene. So same monomer here. Addition polymerization. So this is a homopolymer. Okay. Whereas in heteropolymers, monomers that polymers are called as heteropolymers. Hetero means they may be linear, branched chain, classed chain, and here we can see bakelite, phenol and formaldehyde combination, nylon, hexamethylene diamine and adipic acid combination, terylene, terephthalic acid and antributadiene, and buna-S rubber and buna-N rubber. Buna-S is nothing but 1,3-butadiene plus styrene. So two different monomers are involved. So this is heteropolymer and these are homopolymers. Now, classification based on occurrence, very important. Natural polymers, naturally occurring. Again, these natural polymers are basically natural and synthetic polymers, two categories, or two different types of polymers. Natural polymers, synthetic polymers, man-made polymers. Synthetic are nothing but man-made polymers. Okay, these are naturally occurring. Naturally occurring. Now, these naturally occurring polymers are categorized into two types: inorganic, organic. Inorganic again without carbon. Then what should be there without carbon means like elements: boron, sulfur, phosphorus, oxygen, nitrogen. Inorganic elements. Organic polymers, there should be carbon. Okay, without carbon there won't be organic polymers. Okay, so what should be there in the organic polymers? Carbon should be there, and best example for organic natural polymers is cotton, wool and silk. Now coming to the man-made polymers, that is nothing but synthetic or artificial polymers. Again this is two types, inorganic and organic. Inorganic something like polysulfur nitride based polymers. Organic again categorized into three types: fibers, rubbers, plastics. These plastics again categorized into two types: thermoplastics, thermosetting plastics. Thermoplastics are nothing but, best example is PVC. What is thermoplastic? Which is becoming soft upon heating and becoming rigid upon cooling. That is the thermoplastic. Thermoset plastic, it may become soft upon heating but may not become rigid upon cooling. That means with respect to temperature, this may be molded or cannot be molded, whereas thermoplastics are upon heating and cooling, they will be molded into our desired shape, size, morphology. And the best example, PPE, polypropylene, PS, polystyrene and polyvinyl chloride. These are the examples for thermoplastics. So thermoset plastics, bakelite, nylon 66, these are some of the best examples for the thermosetting plastics. And rubber is nothing but defined based on the elasticity. Fibers are defined based on the filament formation. Okay. Now broadly, classification of polymers is based on two types: natural polymers, artificial polymers. Natural polymers which are coming from the nature or natural sources, like wool, cotton, cellulose, starch, etc. And synthetic polymers are something like artificial, man-made polymers. Best example for the sports coats, mats. And again these are two types: organic, inorganic. And organic, inorganic again categorized into several types based on their molding capacity and effectiveness with temperature. Okay. Now, types of polymers: homo chain polymers, hetero chain polymers, graft chain polymers. Homo, as I said while ago, same monomer is involved in the polymerization. Hetero, two different monomers are involved in the polymerization. And graft, there will be something like branched chain polymerization with different monomers. That is nothing but graft copolymers. Now, the tacticity of polymers, which is a very important topic. Tacticity is nothing but how closely polymer is packed, or how atoms are arranged, or most of the polymers are amorphous. Why these are polymers are amorphous? Because of their property called tacticity. So isotactic, atactic, syndiotactic. Okay. Isotacticity is nothing but if all the functional groups are arranged on the same side of the backbone chain. That is nothing but isotactic. That means functional groups should be attached only one side. Okay. Atacticity, if all functional groups are arranged randomly, neither left side nor right side. So, functional groups are randomly arranged. So, atactic, there is no particular fashion of arrangement of functional groups. Syndiotacticity, if all functional groups are arranged alternatively with respect to the main chain, one after one, functional group, one after one arrangement on the backbone chain or main chain, that is nothing but syndiotactic. Okay. Now, polymerization methods, the process by which the simple molecule or micromolecule or monomers combined through covalent bond is called polymerization. And this polymerization can be done by three methods. First one is AP. AP is nothing but addition polymerization. Second one is CP. CP is nothing but condensation polymerization. And third one is copolymerization. Okay. Sorry. So these are the three types of polymerization methods which are widely used for the synthesis of polymers from the monomer. Okay. Let us stop here. We will continue in the next class. Thank you.